So we're going to work on the iron GT knuckles now, and this is the 1.5" taper per foot ball joint reamer. That's what's in this. All right, that's what's reamed into this knuckle here, but we're going with the 2" per foot reamer. So all I'm showing you, this is how I've been lining them up. Just run, I just have this just loose enough so that this can kind of pivot around once I eyeball the center, and then I run the reamer down in the hole and just get it centered up, sliding around underneath that nut there, and then tighten it up. All right, so it actually has, if I tap down on it hard enough, it actually sticks on that taper. So we're good to go there. I have the jack behind here to help kind of prevent any twisting motion. So we should be good to go. I'm not sure what to expect on the cast iron. I'm hoping it's going to be easier to cut than that aluminum. So we're going to swap this reamer out to the 2" and then we'll get started on it. All right, we got our tables locked. Make sure I tighten up the collet up here. So far, much easier there. All right, you can see it cutting. Let me go ahead and start checking that. Yep, almost there. Doesn't have much more to go. We got to make our sleeves for these guys here, so it'll fit them studs. We just got a little bit more. I'm gonna set a 0 up here on the quill and see how far down I'm going. Still got a little bit more. Does not take much for it to dig in and stall it. That's about where it needs to be, right there. I think we are there. If I can get just a few more thousandths of depth on this, I think it'll be even better. It'll be just touching that seal. Just like that. That's what they want. Just starting to touch the rubber boot right there, and then it's going to lock in just like that. All right, I'm going to clean this cutter off. I'm going to clean this off, and we're going to make us a fresh mark on here in this one, so I know we'll go the same depth on the next knuckle. Let's see if I can get it with the paint marker right here. That should give us a visual reference there to help line it up once we go back into the other knuckle. And I'll get a rag and we'll clean that yellow off there. All right, we just got this one centered up there, again using the other tapered reamer to line up the hole there. I just get everything lined up very, very close with moving the table, and I've got the back of it resting against this jaw over here so it can't like spin around. And then I just line it up with the reamer there and then tighten it up real good. So right there, it's in. It's stuck in the hole. I have to bump the quill like that to get it out of there. So I feel confident that every one of them I've done is probably within a few thousandths of being in the true center of that hole right there. So I think it's going to be perfect for what it is there. So all right, we'll go ahead and swap that cutter out, and we'll get this one reamed as well. All right, so that finishes up all of our knuckle reaming that we had to do there. We got our, I think that was, I'm trying to remember what he called this, the lower forward control arm, I believe is what this one's called, lower forward. And we've got all of them fitting just the way that Tim wanted them to fit in there. They go down and they just touch that rubber boot there, and they should pull in there nice and tight on that taper. So these were tougher than I expected them to be, so these must be some kind of forged aluminum, so they're just tougher. It's not hard, it's just tough. So it was tough on that reamer when you've got the entire length really of that hole all the way around. It's trying to cut that at one time. That's a lot of tool pressure on a reamer to make that kind of cut. But the X-Cut reamers did an excellent job. This is the first time I've ever used these. I just ordered them straight off their website. And this one right here, the 1.5 inch, did perfect for lining up this hole right there, you know. And now I got them in the drawer for, you know, future jobs if I ever have to do something like this again. You can make an extension just like I showed right here for any kind of cutting tool. If you got to run a drill or a tap or a countersink, anything like that where you need that long reach, you know, just do something like this right here. The drill rod really works really good for this right there. That's why I always, Dad's the one that always had a box of this in all standard sizes from like a 1/4 inch all the way up to 1 inch. And so I've always maintained, you know, and kept some of this stuff around there, even in metric sizes as well. So there we go, that's done. Next up, we've got to, on the iron knuckles here, or steel knuckles, I think I keep calling them iron, but we've got to make some sleeves right here, and he asked if I would use some kind of maybe like a stainless steel, so I got to find some stainless, and we'll make a little sleeve to bridge this gap, you know, so the nut will pull down on that. We'll pull the taper up in there and not hit the shoulder. So we got to do that. That's going to be coming up. And then we've also got to mill the pads here. We got to take a 1/4 inch off this surface right there on both of them. And then the studs, we've got to shorten the studs a 1/4 inch whenever we do that. So that'll all be coming up, and we'll get started on that next. I got this piece of 1.5 inch stainless bar stock. I'm just going to cut me off a foot here and use this to make a couple of the bushings, and I'll have another piece here for the drop shelf to work on later. This is a piece that come out of the old shop. I remember we were doing a lot of scrapping. Dad was wanting to scrap a lot of the long pieces that we had, and some of the stuff I had taken and I had cut me like 3-foot lengths of it to keep here in the shop. I've got a little stack, you know, different materials just standing up right here, different stuff on the shelf there. And I don't remember what grade it is. It is non-magnetic, but I don't know the exact grade. Got the brand new saw blade on there for MK Morse, and it looks like it's doing a great job. There it is right there. So here's our steel knuckle with the tie rod in there, and you can see this is where we've got to put a bushing right there. So we're just going to make 2 stainless steel bushings. We're just going to make them 3/4 of an inch long, and that'll allow the nut to have something to pull that ball joint down in that tapered hole. And Tim had asked if I could make it out of stainless or something strong. So since we got the stainless, that's what we'll go ahead and use. Got our stainless chucked up in the Monarch here. We'll go ahead and get it indicated running true. We're going to be turning that OD down from 1.5 inches to 1 3/16 inches. And then we'll probably just drill a hole down the center. Went the wrong way right there. Drill a hole down the center. I may leave enough in there to just kind of lightly skin it out. Unnecessary, but you know how we like to make our parts look nice and finished. I think that's going to be close enough right there. That's within 1. There we go. guys just saw me drill that hole in that stainless bar, and I wanted to show something because we had a little incident happen there whenever we were drilling it. You might have heard that pop at the very beginning of drilling the hole, and you can see right there that's what happened. We had part of our cutting edge break away from there as soon as it started engaging the material there. So since this happened, I thought that I would bring this up as a opportunity to talk about what's going on here. So I reground this drill over on the Lyle, and I didn't set the proper clearance, the cutting edge clearance behind on the land here, okay? And that's the angle tapering back that way, you see? And if you don't have enough clearance, if you have too much clearance back behind the cutting edge like this is an example of what can happen. Stainless is it's not a hard material, but it's a tough material, so it takes a lot of tool pressure to get in there and shear that material. So as soon as I applied a little pressure to it, it snapped that off because it just didn't have enough material behind it backing up the cutting edge there. All right, so I have another. We used a 23/32 right here. That's what this is. It's one of my good drills, and I don't know why these are in there. This is a very old drill that we have used probably thousands of times in my shop. That was probably Navy surplus that my granddad bought. All right, this is another one that's been in my bin as well. It's another 23/32. I went ahead and reground it, and I reground it with more of the proper clearance angle behind the cutting edge there. So you can see we have less angle, so you have more material there to back up that cutting edge. I tightened up the angle of the chisel point there as well. So I thought that I would show this and maybe go over there and let's drill a little bit further and see how the regrind on this other drill does compared to the first one that did right there. So maybe a little hard to see on video, but there is a difference there. Just look at the angle behind the cutting edge there. You can see that one on the left is a little bit steeper angle than the one on the right side. All right, so just a little drill grinding lesson there for you. Hopefully that'll make a little sense and help you guys out too. All right, let's try it a little bit. Just try it again. Just drill up in there a little ways. See how this one does. Feels like it's doing just like it should. I'm gonna go ahead and bring it out, and we'll look at the tip of that drill and see if we can see the cut pattern on it. All right, it did fine. No chipping that time, just like it's supposed to. So just keep that in mind. Just be careful of your clearance angle behind the cutting edge there. Gotta love Mondays. First we had our drill, and then during that finish cut had this issue right here. Flood coolant all over the floor here. So this hose, coolant hose, popped off that barb right there. So I need to redo this in and retighten that up. So I don't know why. Maybe it wasn't on there right, and it finally just blew and it popped off, and it was just pumping coolant all over there. So another good reason to have the pig mats around, a roll of it for emergencies like this. I much prefer to use these over oil absorbent clay, things like that. So I'll just keep mopping this up with the pig mat here. You see it does a good job. See up underneath there? It gets it up. So yay for Mondays. All right, we got enough turn and drill there. We're just gonna part two of these off. Ow. Just doing two of them at 3/4 inches. It's not a critical length there. There's plenty of clearance over the threads. I got just maybe a line past it. We'll touch up that other side with the tool and then give it chamfers there as well. Just do a 10/1000 cleanup on the face there. Using a high-speed tool bit there. That's just a chamfering tool. Works really good on stainless steel. Nice sharp cutting edge. Usually doesn't leave any kind of rolled up burr there. Just like that. We'll do the other one, and then these two spacers will be done. All right, there's our two stainless steel spacers, and this is where they're going to go right here. So just like that, I bored it just over the size of that taper right there, and then we've got the this is the nylon or nylock nut that's going to go on there, and I don't want to run it up and go ahead and cut into that nylock there. So, but that's it. That's what we're going to do. That'll run up there and pull that ball joint right up in there. All right, so this part of the build is done. Now we're going to move on to the next machining segment, which is going to be machining the deck off of the caliper pads on the aluminum knuckles.